The mining process at Copper Mountain Mine. Copper Mountain Mine, located near Princeton, British Columbia, is a large-scale open-pit mining operation that extracts and processes copper, gold, and silver. The mining process at Copper Mountain involves several critical stages, including drilling, blasting, material transportation, crushing, grinding, flotation, concentrate production, and shipment. Each stage is carefully managed to optimize efficiency, maximize metal recovery, and ensure sustainable operations. Mining at Copper Mountain begins with drilling and blasting, an essential step in breaking up solid rock to allow for efficient material extraction. Powerful rotary drills create deep boreholes in the rock, following a precise grid pattern. Once the drilling is complete, explosives are placed in the boreholes and detonated in a controlled sequence. The controlled explosions fragment the ore-bearing rock, making it easier to extract and transport. The process is carefully engineered to minimize environmental impact and maximize resource recovery. Once the rock is broken up, large hydraulic shovels and wheel loaders load the material onto ultra-class haul trucks. These massive trucks, each capable of carrying hundreds of tons of material, transport the fragmented rock to designated locations. Waste rock is transported to disposal areas, while ore is delivered to the primary crusher for processing. The efficiency of this material movement is crucial for maintaining a steady flow of ore to the processing plant. At the primary crusher, large chunks of ore are reduced in size to facilitate further processing. The Copper Mountain Mine uses a high-capacity primary crusher to break down ore into smaller pieces, typically around 6 inches in diameter. The crushed ore is then transferred onto an overland conveyor system, which transports it over long distances to the ore stockpile at the concentrator facility. This conveyor system enhances efficiency by reducing the need for truck transport over long distances. Once at the concentrator facility, the crushed ore enters the grinding circuit. The first stage of grinding takes place in a semi-autogenous grinding (SAG) mill, which is a large cylindrical drum that rotates and uses both ore itself and steel balls to break down the material. The SAG mill is powered by 2 high-horsepower motors that ensure continuous grinding at optimal speed. Water is added to create a slurry, which helps break down the ore more effectively. The partially ground material is screened to separate fine and coarse particles. Coarse material that does not pass through the screen is sent to a pebble crusher, which further reduces its size before returning it to the SAG mill for additional grinding. Following the SAG mill, the ore undergoes further grinding in ball mills. These mills contain steel balls that crush the ore into even finer particles. The ball mills are powered by high-horsepower motors and operate continuously to ensure a steady supply of finely ground material. After grinding, the ore is classified using hydrocyclones, which separate coarser material from finer particles. The fine material advances to the flotation circuit, while coarser material is returned to the ball mills for additional grinding. The flotation process is a key stage in separating copper minerals from waste rock. The finely ground ore is mixed with water and introduced into flotation cells, where reagents are added to create air bubbles. These bubbles selectively attach to copper minerals, allowing them to rise to the surface while waste materials settle to the bottom. The froth containing copper minerals is skimmed off, while the remaining waste material, known as tailings, is pumped to the tailings storage facility. The initial concentrate from the rougher flotation circuit typically contains about 5% copper. To improve purity, the concentrate undergoes regrinding in a specialized mill and passes through additional cleaner flotation columns. These stages remove unwanted impurities and produce a higher-grade copper concentrate with approximately 25% copper. The purified copper concentrate is then thickened to remove excess water. In the thickening process, solids settle, and water is separated, leaving a denser slurry containing around 50% solids. This thickened concentrate is further processed in filter presses, which reduce moisture content to approximately 9%. The final concentrate, now in the form of a dry, powder-like material, is ready for transport. This high-value product contains significant amounts of copper, along with small quantities of gold and silver. Once filtered, the concentrate is loaded onto specialized transport trucks, each capable of carrying approximately 50 tons. These trucks transport the material to the port of Vancouver, where it is loaded onto bulk cargo vessels for shipment to Japan. In Japan, the concentrate is refined and smelted into pure copper, gold, and silver, which are then used in various industrial and technological applications. Water management is an essential aspect of the mining process. Copper Mountain Mine reclaims water from its tailings storage facility, reducing freshwater consumption. Additional water is sourced from local rivers, ensuring a sustainable supply for processing operations. The mine is also connected to a high-capacity electrical grid, receiving power from a 61 megawatt BC hydro substation. This reliable power source ensures uninterrupted operations, allowing the concentrator facility and mining equipment to function efficiently. Beyond current operations, Copper Mountain Mine continues to invest in exploration to expand its resource base. Extensive drilling programs have already increased the mine's copper reserves, and geophysical surveys indicate further potential for new discoveries. By continuing exploration and improving extraction technologies, the mine aims to extend its operational lifespan and maintain its role as a significant copper producer. Copper Mountain Mine focuses on two primary objectives: maximizing production while minimizing costs. By optimizing equipment use, improving processing techniques, and maintaining strict quality control, the mine ensures cost-effective and sustainable production. Advanced monitoring systems allow operators to track and adjust key processes, enhancing overall efficiency. With a well-established infrastructure, strong financial backing, and ongoing resource development, Copper Mountain Mine is well-positioned for long-term success. As one of British Columbia's major mining operations, it continues to contribute to economic growth, technological advancements, and industry leadership.